Looks like we have another hypothesis test here. It says last year, the average amount of money spent per family on jewelry in the USA was $116. This year, a random sample of 66 U.S. families was found to spend on average $98 on jewelry with standard deviation of $21. Use the 5% significance level to test the claim that families this year spent less on jewelry than last year. Okay, so we're doing a hypothesis test. Yeah, let's go red. So step one. Come on, right, please. Thank you. We're going to state the null and alternative. Hypothesis. So the null hypothesis being H0 and the alternative hypothesis being H1. These are going to be about population averages, mu. Remember, the null always involves equality. So what are we comparing the average to? So the claim is that families this year spent less on jewelry than last year's. So we're comparing this year's average to last year's average. What was last year's average? It was 116. So we're going to set the mean equal to 116 for the null hypothesis, right? Comparing the mean of this year to last year's mean, 116. So remember, the null always involves equality. That's why we put equal there. Now the alternative does not involve equality, right? It involves something else besides equality. Now, since it's talking about less than, that's the claim, right? Families this year spent less than jewelry on last year. So we're going to do less than here for the alternative. That's going to be less than last year's was what, 116? This is the claim we're testing. This year's average is less than $116, which was last year's average. Okay, so we got the null and alternative hypothesis. Now we're ready to look at the, scroll please. Step 2. Find the critical values. So first of all, we have to decide, are we using a T or Z distribution? Second, we have to decide, are we using a left-tail test, right-tail test, or two-tail test? So if you read carefully, see that standard deviation of $21? That is in reference to the 66 families that were sampled. So right now, we have the sample standard deviation, right? $21, right? So that is not sigma. That is not the population standard deviation. So sigma is not known here. So because of that information, we know to use a t distribution since we don't have sigma, the population standard deviation. Secondly, we know to use a left-tail test, right-tail test, or two-tail test. A left-tail test. And that's because, well, looky here. We got this guy. Population mean less than $116 is our alternative. So anytime you have an alternative that involves less than, you're going to test the left tail. Okay, so now to find the critical value. No, that was not good. We're going to draw a little t distribution. 0 in the center. Left tail. What color is the left tail going to be? I will just make it pink. How about pink? Not pink, yellow. So what do we know about the significance level we're supposed to test for? It's supposed to be tested at a level of, what, 5%. So the area in the left tail, right here, alpha is 0.05. Right, that's the area in one tail. So if the area in that left tail is 0.05, what about degrees of freedom? Degrees of freedom. Let's call it DF for short. Well, to find degrees of freedom, you're going to take the sample size here, which is 66, and subtract 1. So your degrees of freedom are going to be 65. So take degrees of freedom with area and one tail. And I'm going to find, that's going to give me my critical value back here. This is going to be a T lower star, right? It's going to separate my rejection region from my non-rejection region. Now, keep in mind that this has to be a negative value, right? It's smaller than 0. T lower star is smaller than 0. It's on the left tail, so it has to be a negative value. So now in our table, let's look up 0.05 for area and one tail and 65 degrees of freedom. Let's find my T table here. That's not it. Let's see. Zoom out. Here we go. Here is the T distribution. So I have what? Area and... It's not working too well, is it? Area and one tail was 0.05, right? Yeah. So that's over the top. Right there. There we go. I'm zooming good now. All right, area and one tail is 0.05. And degrees of freedom, what did we say degrees of freedom were? Try to remember, they were 55? No, 65. 65. So we got the area and one tail is 0.05. Degrees of freedom, 65. Where's that? Right there. So you put those two things together. So here we go. You get 1.669. 1.669. Yep. And that's what this guy is. Wait a second. How can it be 1.669? 1.669. It has to be negative. So we got to make sure to change the sign to make it negative 1.669. Yeah. So be aware that when you're looking up something in the T table, it's only going to give you the positive value because the T table reads from the right tail. The right tail. The Z table reads from the left. T table reads from the right. So if you get a positive value and you need a negative value, just make it negative. Make the sign negative. Okay, so we got negative 1.669. All right, so next step. Scrolling. Step 3, we're actually going to compute the value of the test statistic. Compute test statistic value. That's going to be a t-score, which is given by x bar minus population mean mu divided by S over root n. So we got n, remember the sample size, 66, right? What was the sample average? What was the average of the sample for this year? From the sample, we got an average of $98. Spent on jewelry. What was the standard deviation of the sample? It was what, $21? And the population mean mu, we're going to assume, is the null hypothesis for the sake of argument. Oh, come on, don't do that, please. Come on, there we go. Erase. Red marker, done. 116, we're assuming mu is 116 for the sake of argument. It's called the null hypothesis. All right, so we have t equals 98 minus 116 divided by what, 21 divided by square root of 66. Do this computation. What's 98 minus 116? 98 minus 116 is minus 18. And you divide that by 21 over the square root of 66. Make sure you use parentheses around the denominator there. It's going to give you a t-score of, I got negative 6.963. Take the 3 decimal places always. T-scores. Z-scores go to 2, T-scores go to 3. Step 4, we're going to decide about the null hypothesis. Make a decision about the null hypothesis. Well, let's draw a picture of our t distribution. All right, we had a left tail test here. Rejection region was, we called it yellow, I think. We had a t lower star, remember, of right here, negative 1.669. And what was our t value? Our t-test statistic value, green, that was what, negative 6.963. That is definitely over there in the rejection region, right? It's definitely to the left of negative 1.669. So we're going to definitely reject the null hypothesis because our test statistic fell in the rejection region. Okay, so we rejected the null hypothesis. So step 5, our final step is to actually make a conclusion. Summarize. A conclusion here. So how are we going to summarize this? Well, we rejected the null hypothesis, and the claim we were testing was about what? Less than. It did not involve equality. So the claim we were testing, it's called the original claim, the claim we were testing did not involve equality, and we rejected the null hypothesis. So our wording should be, let's scroll to that page where we do wording. Hypothesis test, wording and final conclusion. Does the original claim contain equality? No, it does not contain equality. Did we reject the null hypothesis? Yes, we reject the null hypothesis. So we're going to have what? The sample data support the claim. Sample data support the claim. That's the way we're going to state our conclusion. The sample data support the claim. That, what were we testing? What was the claim we were actually testing? Families this year spent less on jewelry than last year. That, families this year spent less on jewelry than last year. How do you spell jewelry? Jewelry. That's how you spell it. Spent less on jewelry than last year. There we go. That's another hypothesis test. Let's go and analyze a little bit. What was it? It was a left tail test, right? A left tail test. Yeah, that's a left tailed T test. A left tailed T test.